Okay, friends, what we're gonna do out here is we're gonna recreate part of the Excel table that we had in the last video, but we're gonna do it with also looking back at an equation that we developed last class. And here, this is what the last class equation was. Last class's equation was the ending amount in a savings account. Ignore the table for now, just focus on this equation. The ending amount in a savings account was equal to the starting amount. I think we call that the principal, but you can call it starting amount right now. And here's the connection that I want you to see. I'm gonna slide the camera over a little so we can see it better. There we go. Times, and this is where the exponentiation comes in. 1 plus the rate raised to the number of compounds. Make sure we can see all that in the camera. Yep, we can. Ending amount equals starting amount times 1 plus the rate to the number of compounds. Now this was savings account math, which definitely put money in an account, let it sit there. Each year it goes up by a certain percent. And at the end of a certain number of years, you have a certain amount of money depending on the rate. And almost also, depending on the rate, how much you put in, and how long you've left it in. Well, if you think about this and compare it to the math we're doing right here, it's the same. You've got a starting amount. I'm going to add that starting amount up here, $3.35. You've also got an ending amount. After 30 years, which you can't see now, I don't think. I'm going to slide this back. There we go. After 30 years, we know it has to come out being $7.25. But what's interesting is how you get from the starting amount to the ending amount. You have to multiply each year by 1 plus this inflation rate, which we don't know. So that's what we're going to do in this table. Let's take this out and let's apply that equation to this table. So year 1, whatever minimum wage would be in year 1. I know in the last video we made inflation be 5%, and then 3%, and then 2%, and then we just kept guessing. We're not going to do that now. We're going to simply say whatever it's going to be in year 1 is going to be that $3.35, and we're going to multiply that by 1. You know what? Can I just not write the time sign? I'm just going to put the parentheses next to it. 1 plus the rate raised to the first power, because it's been inflated 1 time. Remember again, the 1 stands for the entire 335 is coming forward plus the additional rate that has to be applied to the 335 for the inflation. Also, next year is going to be this raised to the rate again. So it's going to be 335, 1 plus the rate squared. This one right here is going to be 335, 1 plus the rate cubed. Now, last class, we called these things like 1.01, 1.02, 1.03. That's because the 1 was the 100% and the 0.01 was 1%, or the 0.02 was 2%. In the example we just did in the previous video from this class, or this day, 1.05. 1.05. But here's where this is really, really powerful. You see this right here, this 725? This 725 is equal to $3.35 times 1 plus the rate to the 30th power. I want you to take a look at that equation right there. If we can solve that equation, we will have everything we need to figure out what inflation rate on average it took to get from 335 to 725. In the next video, let's do it.